In number 5, it is about the density. The mass and volume of 4 different objects are plotted. Which object has the smallest density? So you can see on the x-axis we have volume, and on x-axis we have, on y-axis we have mass. So let's draw something like this. Suppose this is about mass, this is for volume, and this would be for density. So I'm going to put it like this. The first box is about mass, second is for volume, and the third one is for density. Let's assume for case for A. In A, the mass is 20, volume is 5, and we know density is mass divided with volume, so it is 4. Let's consider the B case. Mass is 20, volume is 10, so density is mass over volume, which is 2. For C, we know that mass is for C, mass is 10 and volume is 5, and density is mass over volume, which is 2. For D, mass is 10, volume is also 10, so density is mass over volume, 10 over 10 is 1. So the question is, which object has the smallest density? So we can see, we can compare with our results. Like A has the highest density because its mass is largest and volume is smallest. In B, the mass is same like A, but its volume is large, so its density is reduced. In case of C, the mass is 10 and density is 5, so its density is similar, its volume is 5, its density is similar to B. And in case of 10, it has smallest mass, smallest volume, so its density is smallest. So our answer is D. Number 6. In number 6, it says, which statement about mass is correct? Mass is density divided by volume. No. Okay, 1 second. Let's write the formula first. So the formula of density is mass over volume. Okay. And mass is density times volume. Okay, now let's see what is the given information. Mass, okay. Mass is density divided by volume. No, mass is actually density times volume. So this option is incorrect. Next is, mass is the amount of space occupied by an object. No, mass is actually the quantity of matter in a body. So it's also incorrect. Mass is weight multiplied by gravitational field. Oh, okay. There is another formula in which we know that weight is mass times gravitational acceleration, and mass is weight divided by gravitational acceleration. This is our second option. So it looks incorrect option. Mass resists change in motion. Yes, it's a inertia like situation. And this is the first option in which object resists against change in its state of rest or state of motion. So this is actually the condition for inertia. Okay, A student produces some revision notes on gravity, mass, and weight. Which statement is correct? A gravitational field is a region in which a mass experiences a gravitational force. Yes, gravitational field is the region in which a mass of, yes. Gravitational field strength has, oh, okay. The first one looks fine, but we will go through rest of them as well. Gravitational field strength has a unit of newtons per kg. Yeah, this it also looks, oh sorry, it also looks fine because if you just look at this option, okay, just look at here, this is about weight, and the unit of weight is newtons and unit of mass is kg. What would be the unit of g? So let's leave g as it is. So move kg to the other side. So unit of gravitational field strength is newtons per kg. So that's why second option is also correct. So we have two correct options. Okay. Let's move to, oh, sorry. These two options are correct. Okay, mass is measure of amount of matter. Yes, this is this is the original definition of mass. Mass is actually the quantity of matter or amount of matter in a body. It's also correct. Mass is equal to weight multiplied by gravitational field. No, this option is incorrect because mass is weight divided by gravitational field strength. So this option is the only option which is incorrect option. Two cylinders. Two cylinders P and Q are made of copper. It means this one is a copper made cylinder. This one is also a copper made cylinder. The height P is twice the height of Q. Okay, this height is half of this one. Like it is, okay. The diameter of P is half the diameter of Q. Which statement is correct? Okay. The density of cylinder P is 4 times the density of Q. Like let's make a little kind of uh, let's calculate their volumes first because there is a difference of volume. Okay, so volume for the cylinder would be base area into height, base area times height. So uh, base area is circular, so it would be pi r square, and height is suppose h. So pi r square times h is the volume of cylinder. Now let's calculate the volume of smaller one. Base area into height is the original formula, but in this case base area is pi r. R is actually its diameter. Like it is given that the diameter is twice, so we can transform it in terms of diameter as well. Like instead of r square we can put like original formula is pi r square into h, but in this particular case I'm going to convert it into diameter form. Over into h, so radius, but it states that height is half, so I'm going to put it as a half for q, but its diameter is twice, so I'm going to put it, oh sorry, 2d over 2 into square. So what would be the outcome of this one? 2 is cancelled with this 2, so our answer is pi d square h and divided by 2. This is the volume of our q, the volume of q. So let's move to this one. So it is pi, and I'm going to put it like r, instead of r I'm going to put d by 2, because diameter is half in case of this long p cylinder, but height is 8, suppose. Okay, so pi, and it would be d square h and divided by 2. So this is the volume of p. Now if you just compare them by increasing the height and decreasing the diameter, and in the like in this problem he just increased the height of the cylinder and decrease its diameter, and in case of q the diameter is increased. In case of q the diameter is increased and height is decreased, and originally its volume is same. You can see in both cases the volume is same. Okay, now their volumes are same, and if their masses are same, then density would be equal. By like if the same amount of matter is there, then their volumes are same, and their density would also be same. So let's see this. Okay, density is mass over volume. So volumes are same. If suppose mass is 10 and volume is suppose 5, just imagine for one case, the density would be 2. Same is the case for the second one. So in both cases, we have same density. So let's move to our question. It states which statement the density of cylinder P is 4 times that of cylinder Q. No, like both two cylinder P and Q are made up of copper. Their material is same. So when material is same, the density would automatically remain same. So this option is incorrect. The density of cylinder P is twice, incorrect. The density of cylinder P is half, incorrect. The density of cylinder P is equal to the density of Q, yes. So trick is that when a material is same, the density would remain same. Whether increase size, decrease size, increase volume, decrease volume, it makes no difference. Its density will always remain same. Number 9. In number 9, it states 4 objects are situated in place with different gravitational field strengths. It means their value of G would be different. Suppose on Earth, Moon, Mars, Jupiter, like on different planets, maybe. Which object has the greatest weight? Okay, so we know that weight is actually mass times gravitational field strength. So mass is given, gravitational field strength is given. We can just multiply them and it would become like this. Okay, so if you multiply 3.5 into 9.5, I think so. Let me use calculator. 3.5 times 9.5, it is 33.25. For third case, it is 4 times 10.2, it would be 40.8. And in fifth case, it is 4.5 times 9, it is 40.5. So the question is, which object has the greatest weight? So you can see 40.8 is the greatest weight. So, okay, it was wrong. So the weight is greatest for this part. Okay. Number 10. 4 rocks on different planets have masses and weights as shown in figure as shown. This is mass and this is weight. So which planet has the greatest gravitational field strength? So weight is W equals M times G. So G would be equal to mass over, oh sorry, weight over mass. So if you, let's for the first one, weight divided by mass. So weight is 14, mass is 2. It would be 14 divided by 2 is 7. 20 divided by 2.5, it would be 8. 21 divided by 3 is 7. 19 divided by 3.5 is, 1 second. 19 divided by 3.5, it is 5.42. So this is the gravitational field strength. So you can see in case of A and C has kind of similar gravitational field strength. It means in both cases, the planets look similar. And okay, so B has the greatest gravitational field strength. So B has greatest gravitational field strength, which is 8. Okay, number 10, number 11. A stone has a mass of 390 grams and density is 2.7 grams per centimeter cube. Cooking oil has a density of 0.9 gram per centimeter cube. Which mass of oil has the same volume as stone? Okay, let's see what is given. So like we know that density is mass over volume. Okay, So actually we are looking for volume, so it would be mass divided by density. So let's calculate this one. This is our mass and this is our density. So 390 divided by 2.7. 390 divided by, oh sorry, 390 divided by 2.7, and your density, your volume is 144.44. Okay, now let's compare the density of the oil is given and mass, like we are going to check which mass will give this answer. Okay, so let's try them one by one. So volume is mass over density. Okay, for the first case, mass is 130 and density is 0.90. This is case A. For A, 130 divided by 0.9. Oh, it gives 144.4. For B, let's try with B. 160 divided by 0.9. For this one, it would be 177.7. Next is 900 divided by 0.9. It gives 1000. And for 1200 divided by 0.9, and it is one. This one is 144. So option A is the correct, is the required option. Okay.